Hello everyone. Today we are talking about credentials management in the cloud. We basically have three different credential types in the cloud: username, password, API keys, and certificates. First, passwords. Passwords, despite their enduring presence, continue to be a primary authentication method. However, their efficacy hinges on adhering to best practices such as complexity, rotation, and secure storage. Cloud platforms such as Amazon Web Services, AWS, offer the means to enforce stringent password policies. For instance, AWS Identity and Access Management empowers administrators to configure policies that mandate users to create robust passwords and periodically update them. This approach bolsters the foundational layer of credential security within the cloud. Let's move on to API keys. API keys are the lifeblood of programmatic interactions with cloud services. These cryptographic tokens, when managed correctly, facilitate secure access. However, their power necessitates stringent control. In Google Cloud, for example, administrators can generate API keys with specific permissions, limiting their scope to only what is strictly required for an application. This granular control prevents unnecessary exposure of resources and data. Finally, certificates. Certificates play a pivotal role in strong authentication, particularly when mutual TLS, transport layer security, authentication is necessary. They provide a robust means of verifying both user and application identities. For safeguarding certificates in a cloud environment, Azure Key Vault serves as a secure repository. Azure Key Vault enables the safe storage and management of certificates, ensuring their confidentiality and integrity. This is crucial when sensitive data must traverse the cloud securely. We move on to credential storage. There are two ways to store credentials safely: secrets managers and key vaults. First, what are secret managers? Secrets managers are the cornerstone of credential storage. They centralize the secure storage and rotation of sensitive credentials, enhancing security and auditability. AWS Secrets Manager, for instance, enables the organizations to safeguard database credentials for applications while automating the periodic rotation of these credentials. This automated rotation mitigates the risk of unauthorized access and potential security breaches. Next, key vaults. Key vaults are instrumental in the protection of cryptographic keys used to secure data. In the context of cloud computing, data encryption is a fundamental practice for maintaining data confidentiality and integrity. Azure Key Vault exemplifies this. It serves as a secure repository for cryptographic keys, offering robust protection for cloud-based applications and services. This ensures that encryption keys remain safeguarded against unauthorized access. Next, we talk about rotation and lifecycle management. Regularly rotating credentials is a fundamental security practice. It diminishes the window of vulnerability and minimizes the risk of unauthorized access. Automating the rotation of credentials can streamline this process. AWS Lambda functions, for example, can be employed to automate the periodic rotation of database passwords stored in the AWS Secrets Manager. By doing so, organizations enhance the security posture and reduce the potential impact of credential compromise. We move on to access control. Managing who has access to credentials and under what conditions is paramount. The principle of least privilege is foundational in this context. Employing identity and access management, IAM, roles and policies, cloud providers like AWS enable administrators to define precisely who can access credentials stored in services such as AWS Secrets Manager. This granular control ensures that only authorized entities have access, minimizing the risk of unauthorized usage or exposure. I've made a whole video about IAM in the cloud, so be sure to check it out if you want to know more about this topic. I'll link the video in the description below. Next, monitoring and auditing. Monitoring and auditing access to credentials is a critical aspect of security. It helps detect suspicious activities, identify potential threats, and ensures compliance with security policies and regulations. Leveraging tools like Google Cloud's Cloud Audit Logs, organizations can track and analyze actions related to sensitive credentials. This level of visibility empowers administrators to promptly respond to any irregularities, further bolstering the security of their cloud environment. Next, a topic which I talk about very often, but it is indeed applicable in many scenarios: multi-factor authentication. MFA is a formidable layer of defense against credential-based attacks. By requiring users and administrators to provide multiple forms of verification beyond passwords or keys, cloud platforms enhance their security posture. AWS IAM, for instance, enables the implementation of MFA for user accounts. This additional layer of protection significantly mitigates the risk of unauthorized access, especially in scenarios where sensitive data and resources are at stake. Credential revocation. Credential revocation is the swift and decisive action of rendering credentials ineffective when they are no longer needed or when there is evidence of a security compromise. Automated revocation procedures are invaluable in this regard. In Google Cloud, for instance, organizations can implement automated processes to revoke compromised API keys promptly. By doing so, they can neutralize potential security threats swiftly and effectively. Finally, compliance and governance. Credentials management is closely intertwined with compliance and governance requirements. It is imperative that organizations align their credentials management practices with industry regulations and internal governance policies. AWS IAM Access Analyzer is a valuable tool for identifying and mitigating unintended resource access. This helps organizations ensure that their credentials management practices adhere to stringent compliance requirements. To summarize and to conclude, we talked about credential types. Passwords, API keys, and certificates are key credential types. Implement strong password policies and limit API key permissions. Next, secure storage. Utilize secrets managers like AWS Secrets Manager for centralized storage and rotation. Azure Key Vault protects cryptographic keys for data encryption. Access control. Follow the principle of least privilege to control access to credentials. Use IAM, roles and policies, for example in AWS, for precise access control. Monitoring and compliance. Monitor credential access with tools like Cloud Audit Logs in Google Cloud and IAM Access Analyzer in AWS. Align credential practices with compliance requirements. These practices ensure robust credential management in the cloud, enhancing security and compliance. Thanks for watching this video. See you in the next.